Hi, pre-calculus students. Welcome to section 1.5, more characteristics of functions and their graphs. Let's see, today we will be working on a lot of things that you already know that you might find kind of easier. But I want to make sure that there's some other things that you know too that you probably haven't seen before. So we have a nice combination here. Okay, so let's take a look at number one. Some important characteristics of graphs would be, first of all, let me say, what have we already talked about? Important characteristics of graphs. We've talked about solution points. We've talked about symmetry, right? We've talked about quite a few things about graphs. So today we're going to talk about relative maximums and minimums and intervals where the function is increasing or decreasing or constant and how to write that. Okay, so when you look at our picture here, right, I drew a point at -2, 3. That is a relative maximum because it is a point on the graph where the y is the highest in this interval. Now, is this point, that maximum, the highest on the graph? No, it's not. This graph goes forever, this cubic, upward on the right. So by no means is it the highest point on the graph, but in this x interval where y's are increasing and then decreasing, the y's must have hit a maximum, and they did. A relative minimum is a point on the graph where the y is the lowest. So notice, like in this x interval right here, the y's were decreasing and then they started increasing as you went to the right, meaning that they must have hit a lowest y value before they started increasing again. So again, is this the lowest point on the graph? No. On the left, this cubic goes infinitely towards negative infinity on the left-hand side of the graph. But relatively speaking, this point is a minimum on this interval. Okay, so what happens then is we do have increasing and decreasing x intervals that get us to those max and mins in between there, right? So obviously a graph would be increasing to get to a maximum and decreasing, right, to get to a minimum. And so when they ask us for intervals on the graph where the function is increasing or decreasing, they are asking us the x's where that happens, right? Increasing means that the y values are going up. They want to know the x's where that happens. Decreasing means the y values are going downward as you go to the right. They want to know the x's where that happens. You can also think of an increasing interval as a positive slope and a decreasing interval as a negative slope. So you can look at it in that way. Also, there can be places on a graph where the y values are constant for a certain x's on a certain x interval, right? Meaning that the slope is 0 and the y values stay the same. So you'll be asked on graphs where, at what x intervals the function is constant. Okay, so we are going to, how do we write these x intervals? There's two different ways we can write them. We are used to set notation. And the way I remember that is because inequalities are set in my mind, right? We have less than, greater than, less than or equal to, greater than or equal to. And we're going to write where this graph over here on the left is the x intervals where it's increasing and decreasing. Then we're going to use interval notation. You probably remember this. This is where instead of using less than or greater than, or the less than or equal to, greater than or equal to, we use brackets and parentheses. And we also use a low value and a high value separated by a comma. So we'll talk about how do you know when to use the bracket and how do you know when to use the parenthesis. So let's take a look over here. Notice we have increasing and decreasing. Let's go ahead and look at our graph over here. First of all, where is this graph increasing? And by increasing, we mean the y values are going up as your x's go from left to right, right, as you move along the graph. So let's start on the left-hand end of the graph, right? So we're starting over here and way over here. I don't mean I'm starting at 1, 2, 3, 4 and -4. I'm starting at negative infinity, right? Okay. Notice as I go left to right for these x's that the graph, the y values are increasing all the way up until it hits the x value of -2. Right after that, as I go left to right, the y values start decreasing. So this is an x interval right here where the graph is increasing. How do I write that? Well, that would be using inequality symbols. These are all the x's that are less than -2, right? Is that a good description of these x's? These are all the x's less than -2. Now, you may say, well, how come we don't include -2? Because the function isn't increasing or decreasing at -2, right? The function, right, is actually has a little slope of 0 right there. And we'll talk about that in a minute, okay? But let's keep going with our set notation. Let's keep going across the graph. So we stopped where x is -2. Notice as we go to the left for these x's, right, the y values are decreasing all the way up to an x of 1. So how do I describe these x's right here where the function is decreasing? Those are x's in between -2 and 1. Okay, again, I'm not including the -2 or the 1. To tell you the truth, you would really not be marked down for putting equal signs under here. But again, we'll talk about that in a minute. Let's finish up our graph. As we start where x is -1 and we go to the right, and really forever to the right if we could, the graph is increasing, right? So we're back to increasing. How do I describe all these x's? These are the x's greater than 1. There we go. So I covered the whole graph from my lowest x to my highest x. Okay, so again, why didn't I put the equal sign? Let's take a look. If you take a look here right before where x is -2 on the left of it, that function was increasing, right? It had a positive slope. Right to the right where x is -2, that function was decreasing. It had a negative slope. So what must the slope be at -2? It must be 0. The only way for you to go from a positive number to a negative number is to go through 0, right? So, and 0 is neither increasing nor decreasing. So I never include the x part of the maximum or minimum point here because the function is doing neither at that point. It's neither increasing or decreasing. Okay, now interval notation, what I would want you to know is that with brackets, that means when you use a bracket, less than or equal to or greater than or equal to. In other words, these match up here. Brackets match up to less than or in equal to or greater than or equal to. How do I remember that? I remember that because this is half an equal sign and there is an equal sign on this bracket right here, right? It just has a big separation in between, right? So parentheses are what you use when you do not have an equal sign, a less than or a greater than, okay? Kind of like you're giving a hug, but not actually touching someone, right? So just for a second, I'm gonna write right here a few examples of interval notation with set notation, okay? And then we'll go ahead and write the increasing or decreasing, we'll erase, okay? So please don't think right now I'm writing these intervals in interval notation. I'm just giving you some examples, okay? So let's say that you had x is less than -2 like we have above. How would I write that in interval notation? Okay, well, we have a picture of it. Those are all the x's less than -2, right? So for interval notation, we have to have a low number, comma, and a high number, right? Well, my lowest number here is negative infinity, right? What are all the x's less than 2? Negative infinity is the lowest. What does it go up to? Negative 2. How do I know whether to put parentheses or brackets? You always have to put a parenthesis on positive or negative infinity because you can't possibly equal positive or negative infinity to put a bracket on it, okay? How do I know if I have a parenthesis on negative 2 or a bracket? I don't see an equal sign, it is a parenthesis. What if I have an equal sign here that x could be less than or equal to negative 2? Then I would say, I see that half an equal sign, I'm going to put a bracket on that negative 2. Okay, so your book uses interval notation a lot. Okay, so let's just go ahead now. That was just a little bit of practice with interval notation. Let's go ahead and write these intervals. Okay, x is less than negative 2. Again, we just did that in interval notation. The lowest x in that interval would be negative infinity. The highest would be negative 2. I would never have a bracket on negative infinity. And I check on negative 2. Nope, I don't see an equal sign. There's a parenthesis. How do I describe all the x's greater than 1? I have to have a low value and an upper value. All the x's greater than 1 that we see here, the lowest value is 1, the highest is infinity. I would never put a bracket on infinity, nothing equals that. On the 1, I will also put a parenthesis because there's no equal sign. Okay, for all the x's in between negative 2 and 1 in interval notation, that's a little easier because I can see the lowest number and I can see the highest number. I don't have equal signs, so I'll put parentheses on both. That is interval notation. Notice if I had equal signs, I would have put brackets. Okay, next, average rate of change. You will be asked in section 1.5 to find an average rate of change on an interval. This is an important characteristic of a function. If you take 2 points on a function and you connect them, and you draw a line, what is the average rate of change on that interval, even though you might have a curve, right? It's kind of important to know how much did it change on average on this x interval. Well, that is called slope, right? So if I take 2 points and I connect a line and I'm looking for the rate of change, that is called slope, right? Which means that I will be using the slope formula here. All right, so students have trouble with this. It's just because they get a little lost. It's easy, but here's what's going to happen, and we'll do an example later. You're going to be given a function, and you're going to be given 2 x's, an x1 and x2. So what do you do? Your job is to put the first x into the function and get the y that goes with it, y1. Then put the second x into the function and get the y2 that goes with it. And then you have everything you need for the slope formula, right? y2 minus y1 over x2 and minus x1. Where students get lost is they forget that they have to find the y1, y2 and just aren't sure where to go. Down here, I just have a list of examples. Okay, now, even in odd functions, you already know about, right? We already did that with symmetry. An even function is symmetric to the y-axis. And if there's a point xy, there's the point negative xy, also on the graph. Odd functions are rotation symmetric to the origin. And they are, if you have an xy as a solution point, so is a negative x, negative y. So you already knew that. It's just that they write it in function notation. Let's remember an x is an x and an f of x is a fancy y, right? So let's take a look here. So even in purple, you knew that if the point xy was on the graph, so is the point negative xy. What does this mean in function notation? It means, notice whether you put an x or a negative x into the function, you get the same y out, right? So that's what this says here. Whether you put an x or a negative x into the function, they equal each other. You get the same y out. In odd function, if there's an xy point on the graph, so is negative x negative y. What does this mean? It means if you put an x into a function and you get a y value out, when you put a negative x into a function, you get a negative y value out, a negative function value. So that's just in function notation. Okay, let's do some examples. I already have number 10 and 16 set up. So on number 10 in your book, they want the domain and range. So I drew a picture and I put D in R for domain and range. Okay, so how do you get domain and range when you're looking at a picture? Domain are x's where there's a y point graphed. Y's are in the range if there's an x point graphed. Okay, so let's do the domain first. As I go across, right, because domain are the x's, so I'm going left to right. Notice as I go across the graph, looking at my x's, everywhere, every moment I go from left to right, there is a point graphed. I could name for every single x as I go left to right, a point on the graph, right? And these arrows mean it goes from negative infinity to infinity. So the domain is all real numbers. The range are the y's. So, and those start low and go high. So notice I'm going to start here. And as I go up the y-axis, take a look here. There's no graph. For these y values right here, there is not a point I can name on the graph. So these y's are not in the range. Let's keep going up. Where's the first y that I come to where there's a point graphed? Right there, right where y equals 0. And above that, for every y, right, there is a point on the graph that I could name that would have that y in it. So in this case, because the graph does not start until y is greater than or equal to 0, that is the range. On number 16, you know what to do if you're given a function in, given a function, right? F of x equals 3x minus 2, right? And they give you an x, you know what to do with it. What do you do when they give you a graph? It's simple. All you do is look at the graph. Here is a graph of f right here, right? Here's a graph of f, here's a picture. And what we're gonna do is rather than put the x of 1 into the equation, we're just going to go to the graph where x is 1 and get the y value. So on the graph, let's go to where x is 1. That's right there. If I asked you to name that point, you would tell me 1, 0. So the output is a 0. Let's go to the function where x is 0. Let's find the y value there, the output. Okay, x is 0 right here. There's the point on the graph. That is the point 0, 1. So when I put a 0 into a function, it outputs a 1. And that's how you find function values on a graph. Let's go on to number 60. Number 60 is on the calculator. I just wanted to make sure that you know how to find, let's see what they're asking for on number 60. I thought I remembered. On number 60, use a graphing utility to graph the function and approximate any relative minimums or maximums. Let's go ahead and write that. So on my calculator, number 60, there we go. They are asking for minimums or maximums. Okay, so I'm going to go ahead and graph. I forgot my calculator, right? So I'm going to clear out my stat plots and my y equals because I was doing a lot with it, right? So we always clear before we begin. Okay, there we go. I'm going to put in negative 2x squared plus 9. 9x, yes, I'm going to do a zoom 6, right? Standard window zoom 6, right? There it goes. Okay, Now, notice it's a parabola that goes downward. See if you can see that a little bit better. Sorry, it's kind of dark in here. There we go. My maximum is just slightly off the screen. So I am going to adjust my window. I'm going to make my Y max a little bigger, right? So I'm going to go to my window. My Y max goes up to 10. I'm going to make it go up to 15 so that I can see that maximum a little bit better and hit graph. There we go. I shouldn't try to do these videos at night. There we go. Notice we have an upside down parabola that looks like this. Okay. Now, without a doubt, I can see a maximum point, right? We know how to identify a maximum, but there's no minimum point, right? These on the left and the right hand side of the graph, this parabola goes downward forever. So there's no minimum, none. Okay, how do we get the maximum? We don't try to trace to it. That's not good enough. We do second trace. And we let them know we're looking for a maximum. So second trace, and the maximum is number 4. Okay, and then all you have to do, it says left bound, just cursor until you're to the left of the maximum. You've probably done this in other classes. And hit enter, cursor to the right. So you're on the right-hand side of the maximum and hit enter, and it wants us to make a guess, right? And we don't have to, it's looking in the right spot. So you just hit enter. That maximum, please remember that a maximum is a point. We'll go to the third place. So you would include not just the X where the maximum is located, but you would include the Y. Maximum and a minimum are points. So you would have an XY. Okay, that was number 60. Number 78, this is the average rate of change. So here's what happens on 78. Okay, find the average rate of change. 78. It says find the average rate of change. And they give you f of x is equal to x squared minus 2x plus 8. And they give you x1 is equal to 1 and x2 is equal to 5. Okay, so what do you do with this? You first put in x1 in to get the y1 that goes with it. So when I put a 1 in, this is 1 minus 2, negative 1 plus 8 is 7. Then you put the y2 in, the x2 in. There we go, to get the y2. Let's see, that would be 25 minus 10, that's 15 plus 8 is 23. I better check, it's late in the day, right? Okay, 25 minus 10, 15 plus 8, yeah, I'm good. Okay, what do I do now? Average rate of change is the slope formula. I have everything I need here. y2 minus y1 over x2 minus x1. Let's see, this would be a 16 over 4, and that average rate of change, or that slope, is 4. Okay, last problem. Number 128. Okay, on 128, find the coordinates of a second point on the graph of a function if the given point is on the graph and the function is even odd. Okay, that's like, what did you just say? You know, let's write it. 128. I'm going to decipher this for you. On 128, they give you 1 point. 5, negative 1. Okay, let's graph that. 1, 2, 3, 4, 5, and negative 1. Okay. Hopefully I didn't go off the screen. There we go. There's the 0.5, negative 1. Here's what they want from you. In the bold, it says, give another point on A they want you to provide another point. So I'm going to make a spot here. If this function is even. Let's not even look at b. They want another point if this function is even. Okay, even means symmetric to the y-axis. So that must mean there's another point over here, right on the other side that reflects over the y-axis. Another way of looking at it is let's make an even graph. Let's make one that goes like that, right? That's fairly even. So that means that there would be, if I had drawn it properly, more even, right? That means that there would be a point right here, if that helps you to actually see an even function, right? So even function across the y-axis. What would this point have to be then? Notice it would have to be the opposite x, so it would have to be a -5. And I didn't move up or down, I just flipped horizontally over the y-axis, so the y stays the same. Okay. So of course on B, they ask for another point if the graph is odd. So they want another point if the graph is odd. So let's erase, right? Because I have an even function, not an odd. Okay, here we go. And let's go ahead and make an odd function. In other words, if you rotated, right, it would land on itself. Let's go like this. Okay, that's kind of an odd function, isn't it? If I rotate 180 degrees around the origin, it lands on itself. And in fact, this point would be right there. What point would that be? It would have to be the same distance from the origin, right? So notice this point would be a -5 and a +1. But you knew this. You knew an even function, the x changes sign and the y stays the same. And with an odd function, they both change. So that is section 1.5. I hope you're having a great day, and I will see you soon.